Okay, hello everyone. Today we will talk about solid principles. Uh, so what is solid? Solid is acronym for 5 object-oriented principles. So you may probably remember from the last classes that maintainability is one of the important feature that development should target it to. So it includes readability, supportability, modifiability, and so on and so forth. So if you follow solid principles, it will make easy to support your system, to design your classes better, to extend them better, and so on and so forth. So the target goal of every programmer is to design a maintainable system that evolve over the time, that can be expanded, and so on and so forth. So to write reusable code that can be reused by different modules, maybe different project, and so on and so forth. So if you not to follow best practices or object-oriented principles, your code probably would not be easily to maintain in extent. It will be kind of rigid, hard to change, and so on and so forth. So to make our life easier, there is 5 principles was introduced, and yeah, you can see them on the screen. So let's probably go one by one through all these principles. And most important principle is called single responsibility. You should always have only one reason to change a class or a method or a module. You should segregate different functions into different classes, and it's called single responsibility. So on the screen you can see kind of anti-pattern. Don't do like this. And on the screen you can see there's 2 examples of a class of circle. So the left hand side is circle that has only one method, get length, and the right hand side class has 6 methods, and we can try to count how many reasons you would have to change this class. So at least I can count 7 reasons on the left hand side class. On the right hand side, probably at least two reasons. So one reason, so left hand side class is also not an ideal. I would prefer to have a separate class just for the circle, to keep only model, I mean the data of the class. And the reason to change the class only if your model, if your data of the class is changed like type, you're adding one more data, and so on and so forth. If you have get length method, so you have another reason if you like logic or formula is changed of get length method. So for get length, probably it would not be easy to change the formula. It's just an example, but still, like if it would not be get-length, it would be like something more complicated. Like there could be some reason to change it. So, but still, this class is better because it has only one method that is like focused on one responsibility. Here, if you like your logic of computation area of a circle is changed, you have reason to change the class. If your get length method will be changed, you have also a reason. And same about other methods. If you like your XML format is changed and so on and so forth. And if you like export to XAML like format is changed, you have also two reasons. So basically it means this class have two-way many responsibilities, and it's not easy to maintain. This class will be fragile. Every developer will change it and so on and so forth, and it can cause like problems other parts of code which like was not affected need to be recompiled and so on and so forth. So left-hand side class is definitely better. Let's think now how we can regroup it, how many classes we need to refactor this method. Probably I would introduce a class called circle calculator, where I put a method to calculate length and calculate area of a circle. So these two methods would receive like a circle object, and they would return like area and length. So another set of classes I would like to create to refactor this class. I would create an interface called like circle saver, where I would have saver method save that accepts circle and returns nothing. So, and of this interface, I would have three implementations. One of them like XML saver, other would be binary saver, and the last one would be like XAML saver. So XAML is also yet another format, but method save and export kind of synonymous. So and when you refactor this, you need to understand that. So they both three classes implement one interface, and each class has its own responsibility, like save to binary format, save to XML, and you now have only one reason like to change like these classes. But for calculator, you have two reasons, but still this class would be very focused on calculation. So let's say to change calculations is one reason. And the last class could be like graphic drawer that have method draw and accept circle and so on and so forth. So we could refactor this into 1, 2, 3, 4, 5, at least 5 classes plus the original one, so it goes to 6 classes. Yes, and here you can see how it can look like. So, and this would satisfy single responsibility principle. These classes would be easier to test and easier to extend. If you need one more like saver, you just need to implement one more class of the interface and so on and so forth. Let's go to the second principle, which is called open-closed principle. It means like your classes, your modules should be open for extensions, but closed for modifications. So open for extension means entity behavior can be extended by creating new types, subtypes. And closed for modification, it means you should like after you created a class, you should not change it, only like to do some bug fixes. But you should not apply this principle directly. Like you still can modify your classes, but I will elaborate on that a bit later. So how can we develop a project that resistance to changes and which exceed the lifetime of the first version of the project? So yes, your class should require only bug fixes, and you should like not change the class, but extend it, adding new like functions through the inheritance. So this is the idea, and let me clarify this principle a bit. So probably not only new function can be added like through the extension, you can still like add methods to existing class, but you should not drastically change the signature, your existing functionality or the signature of your existing methods. It means like to be compatible with previous versions. So let's say we're writing a library that will be used for like many projects. So we're writing kind of Spring or like whatever library. And let's say like if you release a new version and you change something in existing like interface or existing like logic inside existing method, your clients will start behaving like incorrectly. Your other projects that use your library will can face a surprise because like your behavior of your library being changed with a new version. So it's not that we want, like it's better if you like would like to modify your existing logic significantly. It's better to create an inheritance, like name it correspondingly and like override your method and like other projects or modules who was using your class will continue working as they worked previously. But if someone needs a new version, he will use other class. This is the idea of this method. And the other principle called Liskov substitution. It means you should be able easily to replace a parent class to a subclasses or vice versa. So the behavior of inherited classes should not conflict with the behavior of the base class. So behavior should remain like expected. So, for example, if you have two different inheritance, two different implementation of the phone, it still kind of behave in expected way. If you like press a green button, it will make a call. If you press a red button, it will stop a call. So this is expected behavior. But if you change, for example, in other model, you need to call like red button to press red button to make a call and to press green button to stop a call. It will be like unexpected change, and no one like will accept this. So it's also funny picture. Like if you if it looks like a duck, quacks like a duck, but needs batteries, probably you have chosen a wrong abstraction. Oh, yeah, probably it's also about Liskov substitution because like these two entities are not not interchangeable, so we could not replace these two correspondingly. So yeah, because it's like our abstraction is wrong. So let me also a bit expand on that. in terms of coding, let's say we have a class in Java, list interface, and method like remove. If we have two different inheritant, let's say array list and linked list, if you like call a remove method in linked list and like the element like does not exist, it will do nothing, let's say. And this behavior should be like kept the same in all inheritance. So in this way they could be like interchangeable. But if on the one in one inheritant classes you will change this behavior, for example, now if object does not exist and we're trying to remove it, we will throw an exception. Let's say in linked list, but in array list it still would not throw an exception. So this would violate Liskov substitution principle because these two classes are not interchangeable. And let's talk about other principle called interface segregation principle. So many specific interfaces better than one big interface. A client should depend on methods only it use, or it should not depend on method they don't use. So it means like you should not introduce unnecessary dependencies. So let's say we have an interface called item. And it's not Java, it's just an example language. I guess it's probably PHP. You have like here 7 methods in this interface, and this interface quite big, and seems this like they're not really tightly connected. This method. I mean this method. So probably I should mention about 2 other principles which are like loose coupling, high cohesion. So loose coupling, it means also about single responsibility. Your classes should be like be somewhat independent from each other, and like the method inside your classes should be like coherent between each other. That should like form the logical abstraction. Probably in this case the abstraction is like they not form like a clear abstraction, because some methods like connected with like selling item, some method like connected with like how items looks like and like what is the condition and so on and so forth. Probably if we like design a like online shop, probably not all our item would implement all method, and we have to like leave some method empty or throw an exception, which is not really great. And that's why we would like to improve it and refactor this interface into 3 interfaces. Let's say we have interface item that has 2 methods, condition and set condition and set price, which like every item would have. Let's say we have interface like clauses that has like methods that related to clauses like color, size, material. And let's say we have interface discountable that has apply discount and apply promo code methods. And like if we like create entities, and we now can only implement specific like methods that we need to specific interfaces. If like book can implement item and discountable, So, but it does not like color of the book and size of the book, and not really important, and material probably as well. But if we have clauses, we can implement item and clauses interface. So it was interface segregation principle from solid. So yeah, it's better to have several but small interfaces rather than one and big interface. And the last principle, but an important one, dependency inversion principle, which says top-level modules should not depend on low-level modules. Both should depend on abstractions. Not on implementations. So here you can see an example. Let's say we have order process class, and this class uses interfaces, discount calculator, and tax strategy. This class would not use particular implementations like it's like dependent on the interface, and like you create an instance of a particular class and pass this instance like to this class in order to use it like in a constructor or via method and so on and so forth. So you kind of configure like order process with a particular instances. This called also dependency injection. You inject these dependencies into this class. But you should, this order process should not depend on particular implementation, because it will be hard to maintain and hard to change. Like it means, it basically says you should not your like variables should be of type of tax strategy, and you should not like explicitly create new object inside this class. You should like pass this object into the class. So let's say we kind of violate this principle. Instead of like having two inheritance, we have one class, and it is a particular implementation. And if we have a particular specific like case for some country, we are writing like if statement. If it is UK, then do some logic. So it's kind of code that smells bad. That's like this code not easy to maintain, not easy to tense. It's kind of workaround. And you should never do like this. Instead of, if you have specific logic, like if everything like kind of the same inside the class, but you would like to change some particular behavior for some special case, it's better to create an extension of this class. And like you can use, for example, a pattern, like it's a bit different pattern called template method. For example, here you can have like an abstract method that you like have a default implementation in this tax strategy class, but and it's called like inside your calculate method, and you can just extend this tax strategy class and override this very specific logic by like your specific calculations. So in this case, like instead of using like this implementation, you would use an inheritance class. So this like template that I provided to you also is about open close principle. So you should not change it. You should like extend a class and override the logic. And ideally, you should have interface here, and this would be like a US tax strategy, and this class could be extended from US tax strategy, but tax strategy like could be interface. So, and by doing this, you can extend this, and like if we like expand this principle, like to absolute extent. So it means like all your classes should have interfaces and all like they work through the interfaces. But sometimes it's like a bit like a bit overkill, and you can still have like particular classes, but you need to understand like if this class is subject to change in future. So it's better to have interface, and instead of using direct implementation, it's better to reference this class as an interface. For example, like in Java, you are using not like array list. It's better to use like list. If you like define your class and you specify like collection of something, it's better to write like list. In your private field, it's better like a list of suite. It's better to write, and then maybe like in constructor you will like initialize list or like a new array list. But still, maybe in future you want to change this list to linked list. So that's why we need to define the reference itself to list, not to array list. If you in future would like to change it to linked list, you will need to change the reference as well, which is not probably great. So that's why it's better to use always interfaces if they are already defined, or it's better to define interface if you think this class like subject to change in future and can have like other implementations in future. So it was the last principle, dependency inversion principle, which also I previously mentioned loose coupling, high cohesion principles that they are not from solid, they are from GRASP principle, general responsibility assignment software principles. This is like two important principles, low coupling, high cohesion. Also, if you follow a dependency inversion principle, your classes will be loose coupled. It means like will be no like rigid connection between, for example, this class and this class. They will be coupled through the interface, and your coupling, your measure of how classes are isolated will be better. So when you follow like a solid principles, you also like improve, like you also like follow automatically other interconnected principles as low coupling and high cohesion. Yeah. So dependency inversion connected with coupling and open close probably also connected with coupling, but interface segregation and single responsibility connected with cohesion. So cohesion is like measure of how well your class form a logical abstraction. So all methods inside your class should be like interconnected. And for example, let me go back. Here on this side, these classes are not these methods are not interconnected between each other, so they does not form a logical abstraction of this class. So that's why the cohesion of this class is also like bad. And when you refactor into this, so like cohesion will be like better. And yeah, it's interconnected with single responsibility, as I said. Probably, yeah, this is picture that illustrate you that if you need to plug something into like electricity network, for example, you also use an interface. You does not plug it directly, So interface is always good and like make your system like modular and like isolated, independent, and so on and so forth. That's probably it. Do you have any questions, maybe?
Yeah, thanks for the presentation. We have several questions. The first one is about single responsibility principle, how to organize this huge number of classes and interfaces.
Could you expand a bit? I mean, the author of the question, what do you mean to organize huge classes?
Well, not huge classes, but huge number of classes. I think it relates to your example of circle where you extract 6 classes from one, how to organize them in modules and folders.
Well, I would create package for saver. There I would create interface saver and I put all three other implementation for saver. For calculator, I would probably create like other package where I put a calculator. For the model, I would create package model called model where I put like all my classes like circle, point, and so on and so forth. And I would create a different separate package called like drawing or drawer, and then I put like or graphics maybe, and then I would put class for that connects to drawer. So if you have completely, if your classes are like logically completely different, you should put them also in different packages as well. So saver is a great example for separate packages. For other classes, we now have like only one class, but still do not hesitate to create a separate package, because like to put everything into one package, it's not great. Yeah, create packages and to group logically your classes.
Okay, thank you. I hoped we answered your question. The next one is this session recorded? Yeah, let's be a minute of self-advertisement. Yes, this session is recorded. It's uploaded to our YouTube channel. It's called MJC School. And well, it has our logo, so I think you will be able to find it easily. And also the link will be shared in our Slack. Link to the Slack you can find on our website, mjc.school. And on that site too, you can enroll in our free school. So it's more probably for YouTube watchers, not for you. Okay, thank you for listening. Let's go further. The next question is, could you please give an example of high and low coherence modules? I think you answered this question when you gave an example. Circle.
Yeah, I like can probably like say, so if your coherent, we're talking about cohesion, yes. So like when inside circle you have like different methods that not related to each other, like saving, drawing, calculating, they does not form logical abstractions. They are not logically connected to each other. So that's an example of bad cohesion or of low cohesion, which is not great. So you should divide this class into several, and like inside your class, all methods should be like logically connected. This is an example of high cohesion. That's it.
Okay, great. Thank you. And we have one more question. If you have more questions, don't hesitate to ask. We will be able to answer them. This question is, well, more advanced. Thank you for this great question. I was thinking a lot about returning list and hiding implementation, but here are the problems. It assumes that clients don't need methods of particular implementation. So we hide algorithmic complexity total. As far as I understand, it's when we return list instead of array list or linked list.
Right. Yes. Right.
Could you help me understand how this can be neglected?
Neglected. What?
How to solve this problem? So we hide the complexity, the implementation of the list completely.
Yeah, but it's not a problem. I like to hide something that like not like when complexity to hide complexity is good. We don't need to show the complexity because like it's also there is also principle of least knowledge. So you don't need to know about the complexity and about like dependency of something like other modules and so on and so forth. So you only need to use like what you exactly need and nothing more. So you should not rely on the like implementation of linked list. If you are until you are fine with working with interface, you should not care about like if it is an array list or linked list, and there is no reason like to emphasize which like particular implementation you are returning. So maybe author can like clarify this question a bit.
Well, I think complexity is algorithmic complexity. So like getting elements by index is either
Okay.
linear or constant time.
Okay, I understand. So, I could probably explain that when you need a particular, you only use like only return an particular implementation if you need a particular implementation. So if you for some reason need a linked list, and you could not like tolerate array list, you for sure like need for this case linked list. So that's why that means you like no longer like implementation is matter for you. So and it's okay to return a particular implementation if it is important for you, but until it is not important for you, until you like does not rely on very specific logic of a linked list or of something, so you can still use like interface. So and this like should be thought like in the method who returns your list, and in this like time when you create a particular like object, inheritance object, you should think what is better to return in this case, like array list or linked list. Because if you are returning like lots of objects, probably it's better to return array list, and in general array list like performance perform very good, even like if you like try to insert it in the middle or delete it from the middle, still performs very good. So like probably only in like 2% or like in 3-5% of cases it is important for you like which particular implementation you are using, but in general it is not important. And it like linked list, array list, like it is very particular case, but this principle is a bit broader. Not always like you have difference in complexity and so on and so forth. Like until you can define this like on interface level, please do define that. So if you need something very, very specific, if you care about how it is implemented, yes, then you can return a particular class. But it's like array list and linked list. It's a data structure. So like also kind of model. It's not like it's not pure stateless class with calculations and so on and so forth. Probably here like it is also makes different. But if you say if you have like two savers, the one saves to binary and the one saves to like XML, yeah, you should probably you also like care about like which format you want to save, but still you can use like general saver, and it is not important for you and when you save it in which format it will be saved, because it's like kind of externally configured which saver you will be working with. So for array list, linked list, this is a bit tricky if you want with algorithmic stuff and so on. You still can define a reference like inside your code on a list and create a linked list, but use all these methods and you will know the like complexity because you created linked list. But when you're returning a method, an object from the method, it gets a bit more tricky. Well, like if you care about like performance and this for you extremely meta, so you have two options: either you put it in Java documentation in Java doc, or you return a particular like instance, not an interface, particular like implementation. But also as a comment, when you doing performance optimizations, it's usually like your readability, your maintainability usually degrades. So when you start into returning like particular instance of a class, a particular, I mean, inheritant object of a class, your maintainability also degrades and get worse. So you can still return, but like a particular inheritant class, but your code will become a bit less maintainable. So I would recommend to use interfaces until you can. Or if you cannot, then yes. So I hope I answered this question.
Yeah, I think so. Thanks a lot. Yeah, I think we don't have any more questions, and on this point we can wrap up our late talk. Thank you guys for joining in, and thanks, Philippe. It was very useful and interesting.
Okay, thank you very much. Bye-bye.
Thank you. Bye.